Hello, sir.
Okay, just give me a minute. We'll be starting in a couple of minutes, huh? So just be ready. All right, guys, please turn on your camera. We'll start the class. Prakal, Danny, Ibrahim, Syed. We'll start the workshop as soon as you guys turn on your camera. And if anyone is having any concern, you can just let me know. Prakal, Ibrahim, and Syed, are you there? Ibrahim. Prakal, how many people normally attend these classes? Like, I'm not sure about this.
So normally 20 to 30 people.
Yeah, I think they are just putting reminders in the group. So maybe they might take 1 or 2 more minutes. We'll not be waiting for long, just maybe 1 or 2 more minutes. So how's the preparation going, guys? Syed, which set are you from?
I'm from online batch, Homie O12.
Omi or 12. Okay. And how's the preparation going?
It's okay. It's okay. Maths is okay. Physics, chemistry is a lot challenging.
Physics, chemistry is like this is like the opposite of what I normally hear from people. People normally face more challenges in maths. Okay. And how
Okay.
was your JE? Like, have you attempted JE?
Uh, I did attempt, but counted as a negligible attempt. Hope you understand.
I do understand. So let's count the second one. I hope we'll make the second one count, right?
Yes, yes.
So you're joining from India right now,
No, I'm based in Saudi,
based in Saudi. Okay, where in Saudi?
Riyadh.
Riyadh. All right, fine. Prakalp, where are you from?
Yes, sir, can you repeat?
I'm asking where are you from?
Sir, US.
Nice, good. Okay, Ibrahim, can you hear us, bhai?
Yes, sir.
Can you please turn on your camera? Prakalp, how's the preparation going, man?
Sir, it's going good. Chemistry is most difficult right now. Physics and maths is okay.
Physics and maths is okay. Okay, if I ask you particularly maths, which part is troubling more?
Sir, differential equations.
Differential equations, linear differential equations,
Sir, generally like the full chapter.
the full chapter. All right. So maybe like whenever we'll be having time for that, or if you have already done that, I'm not sure about that. But if you'll be needing more classes on that, you can just raise a request and maybe we can arrange more classes. Right? So people have started to join. I'll do one thing. I'm not the host. No. Give me 1 second. Yeah. I'll just ask them to remove the waiting. Wala. So we'll very quickly go through the theory part and then we'll be doing questions based on these, right? Just 1 second, I'm asking them. Bilal and Rohit, can you guys turn on your camera? Chalo bhai, let's start with the first topic, continuity. I hope you guys are already aware of continuity. You know, we'll be covering a lot of topics in one class, so my pace is going to be bit faster. So you guys will have to stop me wherever you feel I need to slow down or I need to explain something again, right? So continuity is the first thing that you'll be discussing. In 11th grade, you have already studied limits and derivatives. So little bit part of that you have already understood. So I'll just tell you what do we mean by continuity. Let's say this is a function y equal to f of x is given to us. And there is a point, let's say x equal to c given to us. So what exactly we'll be having in this case is limit of x tending to c minus, which is x tending to c minus f of x. You know, we call this as LHL, and limit of x tending to c plus f of x. You know, we call this as RHL, left hand limit and right hand limit. So whenever the case is that the limit is existing, so LHL is equal to RHL. And also one more thing is happening. What is happening? That your value of function at that point is also equal. So whenever your LHL equal to RHL equal to the value of function at C. So in this case, see, I'll not be going into depth and like the theory part, how we started this chapter initially. Very quickly, we'll be visiting all the concepts and then we'll be just directly moving on to questions. So if these three conditions are existing, then in that case, we'll be saying that the function f of x is continuous. In this case, we'll be saying function f of x is continuous. So I hope you do understand this definition. Right. And after this, we will be moving on to when can we say a function is going to be discontinuous or what are the type of discontinuities that we'll be having. So next topic that we'll be having here is, so if you don't understand, guys, I'll not be able to ask each one of you again and again. So wherever you don't understand anything, just raise your hand. Just let me know. I'll stop there and I'll explain the whole thing again. Okay. Next is if we talk about types of discontinuity. Types of discontinuity, I hope you do understand. There can be certain reasons for a function to be discontinuous. First reason can be like basically we will be dividing these into two parts. First is removable discontinuity, like whether we can make that function as continuous or not. Removable discontinuity, and this has sub parts. Like first is missing point discontinuity. एक second here, just 1 second. Yeah. So missing point discontinuity, I hope you guys know what do we mean by missing point discontinuity. So if let's say we're having a function like this, and at this point this function is not defined, and further also this point is defined. So in this case, your LHL equal to RHL, but let's say I'm again calling this point as C, but f of C is not defined. When this function will not be defined. So why I'm telling you all this? Because this might be there either in the assertion region questions, right? Assertion region questions, or this might be there in your MCQ questions, like type of discontinuity you might have to identify, right? And I hope you know the chapter structure, like what exactly will be asked from this question. The chapter, not just continuity, the CND part, whole CND will be coming there for, I think, 7 marks. If you guys have a little bit of update about this chapter, CND chapter is going to be there for 7 marks. There will be two questions MCQ, which are like 1 mark each. Okay. There is a probability of one question that we'll be getting this as assertion and reason from this chapter, 2 and 1, 3. And then we'll be having one question as not 7, I think 8 marks. 2 to 4, 3, 7, 1, 8. Not 7, we'll be having this for 8 marks, and we'll be having one question for 2 marks and one question for 3 marks. This is the pattern that we'll be having for this. So this chapter, C and D complete, continuity and differentiability combined, will be having for 8 marks. 2 MCQ questions will be there, one assertion region can be there, one 2 marks, and one 3 marks question can be there. So the reason why I'm telling you all this is either this can be asked in the assertion region part, or this might be asked in the MCQ part. Okay, this was your missing point when LHL was equal to RHL. Second kind of discontinuity can be isolated point discontinuity. Isolated point. I hope you have heard this name. If not, you can just see here. So what exactly do we mean by isolated point? Like this value is something else. Let's say the limit was L, and this value is some, let's say, K value is there. For this, so what exactly we are having? We have LHL equal to RHL equal to LHL equal to RHL equals to L. But f of C, you have some other value K. If something like this is there, you will have to redefine the function. If you redefine the function and you say ki I am changing the definition of the function, f of x equal to whatever is given, and then for, let's say, you'll be saying x not equal to k ke liye, whatever definition you are having, you can have the same thing. But for x, x equal to c, why I'm saying k, just a second. For x not equal to c, whatever definition was there, that can keep going. But for x equal to c, you will say the function will be defined as k. So in this case, you'll be redefining this as L. When you'll be redefining this as L, then we will be making it continuous. So in this way, we can make this discontinuous function as continuous, right? So this was your isolated point. So why we are calling this as removable discontinuity? Because LHL was equal to RHL. If LHL is equal to RHL, then this is going to be removable discontinuity. Second type is non-removable discontinuity. Non-removable discontinuity. Non-removable discontinuity. The first thing is for this is going to be that the limit will not be existing, right? Limit is not going to exist. So first is going to be finite discontinuity. Finite discontinuity, what do we mean by this? Means like this is the function, this is the function, and the LHL is going to be, let's say, L1, the RHL is going to be, let's say, L2. So when LHL and RHL are not equal, we can't do anything to make this function as continuous. Definitely this function can't be continuous, right? Ibrahim, I hope you understand. Are you even paying attention?
Yes, sir.
All right. Syed, Bilal and Rohit, please turn on your camera, guys. Okay. So second case is going to be infinite. Second case is going to be infinite when either the LHL or the RHL or both are going towards infinity. So something like this. Even if I ask you about the graph of ln x, if I give you a graph like this, let's say I'm giving this as y equal to ln of x. So if I ask you at 0, you'll say at x equal to 0, the graph, बताओ, is this graph going to be continuous or not? At x equal to 0, is the graph going to continuous or not? Yeah, this is another discussion. I will leave this for now. This will be continuous. Okay, let's not take this. So I'll be taking another example. I'll show you that thing later. Let's say a function is going to plus infinity here. from both sides or either side or one side, when the LHL or RHL or both tends to plus infinity or minus infinity, in that case we'll be saying the limit is infinite. Then we'll be saying that the limit does not exist. Limit does not exist. Limit does not exist. This will short mean function is discontinuous. Function is discontinuous. Right? Next part, third is going to be oscillatory. Oscillatory. I hope you do understand what do I mean by oscillatory. Right? Like if you are having f of x as sine of 1 by x, sine of 1 by x. So you know when x will be approaching to 0, when x will be approaching to 0, Vedanukesh. This function will be coming like this, but when x will be approaching to 0, this will be fluctuating or oscillating the value very, very quickly. So you'll not be able to understand sine of anything. That value is going to be finite, but not unique. Not unique. Because this value is not going to be unique, therefore the limit will not exist. Limit does not exist in this case also. And if limit doesn't exist, this directly means that the function is discontinuous. So if you understand this part, we can move on to the next, right? Next part is going to be continuity in an interval. Continuity in an interval. Continuity in an interval. So if I have to tell that a function is continuous, something like this, if I have to tell that, let's say this is the value x equal to a and this is the value x equal to b. If I have to say that this function is, let's say, y equal to f of x, and if I have to tell you that for y equal to f of x to be continuous in the closed interval a comma b, the condition are going to be y equal to f of x has to be continuous in the open interval. Continuous in the open interval. Second part is going to be y equal to fx. Can you guys tell me y equal to fx? It has to be right continuous. Has to be right continuous at x equal to a. Right continuous at x equal to a. I'll tell you what does this mean. And third point is y equals to f of x has to be left continuous at x equal to b. At x equal to b. So because we don't know whether the function will be defined to the right side or not, we don't know whether the function is defined on the right side of this or not. So we will not be talking about any of this thing, only the limit. So what exactly will be the case in both of these? I'll tell you that. See, we will be using these things. That's why I'm telling you this. You will have to use this thing. I'm saying y equal to fx has to be right continuous. The meaning of this is limit of x tending to a from the positive side is going to be equal to f of a. This is how and why I'll call that this function is going to be right continuous. And similarly, if I have to tell you about the left continuity, so what exactly will be happening here? We'll be having limit of x tending to b minus f of x. This has to be equal to f of b, right? So I hope this is clear to you guys. What exactly do I mean by left continuous and right continuous at these 2 points? If these conditions are happening, then we'll say that the function is continuous in the interval. Yes, guys, now just look at the graph once again. I'm drawing the graph for y equal to ln x once again. Yeah, if I ask you, is this function right continuous at x equal to 0 or not? Please tell me. Raise your hand if you know the answer. Check whether y equal to ln x is continuous. मैं पूरा ही बोल देता हूं. Is continuous at x equal to 0. Let's say I'm saying. Raise your hand if you know the answer. बोलो भाई प्रकल्प क्या हो गया? No idea. The limit is approaching infinity, man. The limit is approaching infinity. Limit has to be a finite value. The condition is LHL equal to RHL and non-continuous, discontinuous, definitely. So wherever we have written LHL equal to RHL, we have to, okay, wherever we have LHL equal to RHL, that place we have to write that both of these will have to be equal to a finite value. These will have to be equal to a finite value. As long as these values are finite, we can say that this function is continuous. If this is not the case, then we'll say the function is discontinuous. So you can see at x equal to 0, the function value or the limit, the right hand limit is approaching infinity, negative infinity, still this is going to be discontinuous, right? So this is done. This is done. If I ask you single point continuity, do you guys know about single point continuity? This can also be a very good 1 mark question or assertion reasoning question. I'm taking all the cases wherever they can make assertion reason or MCQ, right? All the, like, I do understand LHL you will find out, RHL you will find out, you'll compare those places, you'll not be losing marks. But these things, this is mentioned in your NCRT. If it's mentioned in your NCRT, definitely that can be part of your paper, right? So single point continuity, if I ask, batao, do you understand this? So if let's say a function is defined only at one place, let's say I'm saying f of x equal to, if this is let's say 5 for x equal to let's say 2. So this is only defined at one point. So we don't have its neighborhood. Let's say this is x equal to 2 and the value we are getting is 5. If it is defined only at one point, if it's defined only on the one point, because left side is not in the domain, we will not be talking about the left hand limit. Because right side is not in the domain, so we will not be talking about the right hand limit. Definitely this function will be saying that this is continuous. So we'll be saying f of x equal to, f of x is continuous even though this is a single point. This is continuous at x equal to 2, and this kind of continuity we will be calling as single point continuity. So if you have doubt in this part, please let me know. To verify LHL or RHL, we need to have that in the domain. That's only when we will be able to check their value in the left neighborhood or the right neighborhood. If that's not given, we will not be able to talk about their continuity. Okay. Next, almost done with the continuity. Just last thing, algebra of continuity. Okay. Algebra of continuity we are having. So what exactly do I mean? First, if y equal to fx, guys, I will not be able to continue if you guys don't turn on your camera. So there is no point of continuing the class. Ibrahim, if you don't want to attend, you can let me know, guys. Same for you, Bilal. Same for you, Rohit. Same for you, Nukesh. And same for you, Shiloh. Network issues for Rohit, so it's fine. Ibrahim has given a reason before for something else. Veda and Shailu and Rohit, if you guys don't want to turn on your camera, at least you should be having a valid reason, or you please turn it on. Else there is no point in continuing this. 2 minutes. All right, Shailu. Bilal, Veda. So if you guys don't respond in next 2 minutes, I'll have to remove you guys. I'm sorry. I'm eating. So you can eat with you. Come on, you are eating. Then what focus you'll be having towards it? Okay. If y equal to fx and y equal to g of x, these are continuous at x equal to let's say a, right? Then you will be having first case f of x plus minus g of x will be continuous. This is going to be continuous at x equal to a. Second part, f of x into g of x. This will be continuous at x equal to a. Third, f of x by g of x. This will be continuous at x equal to a as long as your g of a, as long as your g of a is not 0. G of a is not 0 or limit is not 0. Both the cases you can take. ठीक है So I hope that is sorted. If you have any doubt in this part, you can let me know. Okay, Bilal. I think I missed your message then. Acha, you written a message. Fine for you, Bilal. And Veda, please turn on after the class. You guys have any doubt from the chapter of continuity? You can let me know, or else we'll be moving on to the differentiability and differentiation. And in the end, we'll be doing the questions. If you have any doubt from the chapter of continuity, this is your call.
Sir, I have two things to ask.
Okay, please ask.
In the continuity chapter, we have this 0 by 0 limit. What are the different ways to solve 0 by 0? There are so many. So could you just summarize them? Like, could you name them?
0 by 0 limit you are having.
Yes, sir.
So you can have multiple ways to solve that. You can have factorization, right? You can have
Yes.
rationalization. Then you can use standard form. Standard form.
Okay, that is
Standard form,
sin
I'll
x
tell
by
you.
x, right?
Sin x by x kind of thing. Limit of x tending to 0, sine of x by x equal to 1. These kind of things you can have. For JEE, you can use L'Hopital also for MCQs. I'm saying for MCQs only. Please make sure. You can use L'Hopital also.
Yes, sir.
है ना? For MCQs, you can use this also. So you can use factorization, rationalization, or you can use some standard forms, 10x by x, 1 plus ln x by x, right? 1 minus cos x by x square. So all those standard forms that you studied in the chapter of 11th grade, that you'll have to use here. Or if even if you have not studied for CBSE, definitely while preparing for JEE, you would have definitely studied those forms. So those are acceptable. Those standard forms you can use to solve this. MCQs you can use solve using L'Hopital also. Is it fine for you, Sayyid?
Sir, but then like there's this another one. Like if you have to find left hand limit, you put in x minus h, where h tends to 0.
Definitely, that method we call as substitution.
Okay. Now,
That
where
method
can
we call as
substitution be used? Because I just used substitution in a question today and the answer was completely wrong. I mean, I
Can
did
you give me the
substitution. I
question?
actually proved 13 is equal to 11. So, yeah.
Very good. Definitely something great you've done. Can you tell me the question? Do you have a question with you right now?
Yeah, it's just right here. Okay. F of x is
Please.
equal to
Hmm.
x plus 3 whole square minus 36
X plus 3 whole square minus 36
by x minus 3,
by x minus 3.
where if x is not equal to 3,
This is the definition when x is not equal to 3. Okay, fine.
yeah. And then the second definition is k if x is equal to 3, and we have to find find k if it is continuous at x is equal to 3.
This is given to us as continuous. So for sure, one thing we know ki LHL will be existing, will equal to RHL also, and whatever value we'll be getting, that value will be equating to K, right? So in
Yes.
short, this is a question of finding limit. So all that you have to do is you have to just find the LHL. So let's say if I talk about finding LHL, that is going to be limit of x tending to 3 from the left hand side, f of x, that is x plus 3 ka whole square minus 36 by x minus 3. So you just tell me one thing, where does this limit approach? If x I'm putting as 3, so 3 plus 3 will be 6. 6 square is 36. Definitely you can see this limit is approaching to this is the form 0 by 0 form, approaching to 0 over approaching by 0, say it right.
Yes, sir.
So you want to put x as 3 minus h, is that what you want to do?
Yes, 3 minus h.
3 minus h you want to put. Okay, so what exactly you'll be having, you're saying ki limit of h tending to 0, right? And you'll be putting x as 3 minus h plus 3 whole square minus 36 by 3 minus h minus 3, something like this, right? Now you'll be having here 6 minus h ka whole square. You'll be having limit
Yes.
h tending to 0. You see this will be gone. This will be gone. So you'll be having 6 minus h whole square minus 36. Okay?
Yes,
Upon
sir.
minus h. This will be here. Now I'll be trying to open the numerator. trying to simplify the numerator. 36 plus h square minus 12h minus 36 by minus h. So this plus 36 minus 36 will be gone, right? And I'll be taking h common from the numerator. I'll be having h minus 12 there and minus h in the denominator. This will be gone. And when you'll be substituting 0 here, you'll be having 0 minus 12 by minus 1, which is 12. So neither I'm getting 11, neither I'm getting 13.
Okay. Yeah, I must have made an error in h square somewhere. That is why, h minus 12h I must have done somewhere. That's why.
So I hope
Okay.
you'll be able
So
to do it now. Yeah,
yes,
please,
sir.
please.
I was actually able to do this by writing 36 as 6 square. उससे factorize हो जा रहा था. लेकिन
And then using the identity of a square minus b square, right?
yeah. But then ये method थोड़ा और straightforward है, so मैं इसी को पहले कर रहा था.
No. The best is factorization and rationalization. If you are able to do questions using those methods, please don't look for any other thing.
Okay. By the way,
All
just
right.
one more question. This approach
Yeah,
can be
please,
used for
please.
any question.
This approach can be used for any question, yes. But this
Okay.
is preferred in the cases of trigonometry. This approach is preferred in the case of trigonometry. Like you will be having questions like limit of x tending to pi by 2. So in that case, like wherever you will be having some cos of something x or something. So that cos of pi by 2 minus h will make it sin h or something.
Mhm.
This is where this approach is used majorly.
Okay.
I hope you understand this, right?
Yes.
Prakal,
Yes, sir. Sir, in some questions is given like express integration as a sum of limits. So, like, how do we solve that?
integration as a sum of limits, that is an altogether different topic. कर लेंगे अगर if we have some time afterwards, definitely we'll do it. वो
Okay,
r
sir.
by n बनाने वाली फॉर्म, r by n वाली फॉर्म ना,
Sir, I'm
ठीक
not
है?
sure about that.
Not sure, I'm telling you, 1 by n will be dx and r by n will be x. So that's how we'll be taking the limits. So if we'll be having time, so definitely we'll be moving to that also, right?
By the way, sir,
और
this
नहीं तो
question by Prakalp, this is in CBSE?
Yeah, it's there in the NCERT exemplar books as well.
Acha, exemplar.
एक
Okay.
मिनट, just
That's why I've not seen
let
it.
me visit. No, exactly, that's my point also. That is a part of definite integration, and definite may I don't remember seeing those kind of questions. ये तो common आएगा ना, I think the NCERT is common. Shailu must have solved this question. Shailu, have you seen these kind of questions in the NCERT?
Sir, I'm not really sure what he's talking about.
Express the given integral as as a sum of limit. Given sum of limit as definite integral. That part. अब नहीं है यार ये. I don't think that is still a part of the syllabus प्रकल्प. Most probably though it's not there. JEE में yes it is still there, but CBSE we don't have that.
So, like, even in the NCERT website, the current exemplar book, it's still showing the questions.
नहीं, exemplar book ठीक है. Exemplar is not just for not for the board's point of view. No, exemplar is a help book for JEE basically.
Okay, sir.
ठीक है. These properties are there और उस property के बाद है नहीं वो, so you'll not have to worry about it. ठीक है. होता तो definitely they would have given some miscellaneous example based on that or something like that. Express this नहीं है, बिल्कुल भी नहीं है. ठीक है. So you'll not have to worry for that.
Okay, sir.
Okay. Yes. So this is there, and one plain statement that we always say is, one common statement that we say about continuity is, I think you guys already remember this, that polynomial है ना, logarithmic, exponential, trigonometric, these functions are continuous in their domain. These are continuous in their domain. Right? So this is something that we'll have to take care of while solving the questions, and this we can use directly while we are solving the questions. Okay. So this is sorted from theory point of view. We are sorted. If you have any more questions to ask from continuity, quickly let me know. Then we'll be moving on to the next chapter. Chalo. Next is differentiability. Differentiability, I hope you do understand what do we mean by differentiability. Like when a function is differentiable or whenever we are able to draw a tangent at a point, if we are able to draw a tangent at a point, definitely it should not have a sharp edge, right? So there should be a possibility of making a tangent at that point. So I'll just go by the definition. I'll just go by the theory part, which is relevant to our questions. I'll not go into deep, like showcasing you how the point is coming, the secant is becoming tangent, all that. Like we're past that stage now. So definitely, if let's say y equal to f of x is given to us, and we need to check the differentiability of this function at any point, let's say x equal to c. At this point, let's say we are checking whether this function is going to be differentiable or not. So we will be finding two things. First thing we call as left hand derivative. Left hand derivative. And this in short we call as LHD. LHD, and this is going to be limit of x tending to आएगा क्या बताओ h tending to 0 f of c plus लेफ्ट है ना तो f of c minus h minus f of c by minus h. So this is what we'll be having here. And similarly, if someone ये LHD था ना, similarly if someone asks us about RHD, this is going to be limit of h tending to 0 f of c plus h minus f of c by h. So this is how exactly we'll be finding the left hand derivative and right hand derivative, right? At any point, let's say we are trying to find at x equal to c, this is how we'll be finding. But if we have to just find the derivative, if we have to find, let's say y equal to fx is given, and we have to find its derivative. Derivative, you know how we denote the derivative? We denote the derivative as f dash x, or we call this as y dash, or we call this as y1, or we call this as dy by dx. There are multiple ways of representing the derivatives. I hope you agree with me, right? So f dash x or y dash or y1 or dy by dx, or if you guys can think of anything, you can let me know. Okay. So this is exactly what we'll be doing. So f dash of x is going to be limit of h tending to 0, f of x plus h minus f of x by h, or this will be having limit of h tending to 0, f of x minus h minus f of x by minus h. This is how you will be finding the derivative of any function. So sometimes they will give you questions like find the derivative of this function by the first principle. I hope you understand this is first principle of finding the derivative. The chances are less, but still there are questions in your NCERT. First principle, uh, you find derivative using the first principle. So let's say if you are given question of the type like find the derivative of y equal to 3x square minus 7 using first principle. If the question is something like that using first principle. So I hope you guys can do it, right? करोगे try? Just give it a try very quickly in 1 minute, and then I'll be helping you solve this. Do it very quickly. I hope you guys are done. हो गया क्या? हाँ, आंसर तो मैं डायरेक्टली बता दूंगा. आंसर इज नॉट डिफिकल्ट, आई नो. जस्ट solving this with the first principle can be slightly tricky. So yeah, if this kind of question is asked in an exam, so just do it quickly as limit of h tending to 0, f of x plus h. So 3 times of x plus h whole square minus 7 minus 3x square minus 7 by h. This is what we'll be having. So 3x square plus 3h square plus 2xh into 3. 6xh minus 7 minus 3x square plus 7. So this 7 minus 7 will be gone. Minus 3x square plus 3x square will be gone. And the h is approaching 0 still. So you'll be left with 3h square plus 6xh. Limit h tending to 0. 3h square plus 6xh, I'll be taking h common, so 3h plus 6x by h, this will be gone. When you'll be putting h as 0, so we will be just left with 6x. So there might be a possibility this kind of question is asked in an exam, right? And this is how you'll be solving these kind of questions. All right. Next, moving on to algebra of like some basic rules. So this is how you'll be using the first principle. This is how you'll be finding differentiation of any function using the first principle. Now differentiation of some standard functions. Differentiation of some standard functions. I think till now we all should be knowing all of these, right? Not just one. So if let's say y equal to x to the power n is there, y equal to x to the power n. Can I take this slightly advanced version like ax plus b to the power n kind of things? Right? Just let me just tell my parents that I'm on a meeting. You guys quickly revise this. I'll give you few. Yeah. Syed, can you firstly tell me the difference in the first one? dy by
Yeah,
dx?
that will, yes, sir, that will be n 8 a times n to the n times that ax plus b to the power n minus 1.
To the power n minus 1, and then ax plus b will be differentiated. We'll be getting a here. Yes.
A, yes.
Second one, I think we'll be having e to the power ax plus b will be as it is multiplied by differentiation of this, which is just a. ln का आएगा 1 by ax plus b, like yes, dy by dx I am talking about, into differentiation of ax plus b. Sine आ जाएगा dy by dx, will be having this as sine of something is cos of something. So cos of ax plus b multiplied by the differentiation of ax plus b, which is a. Similarly, this cos of something, we'll be having this as dy by dx as minus sine of ax plus b, and the differentiation of ax plus b, which is again a. tan का आएगा sec square ax plus b, and again a. Right, अब मैं I'll write the simple ones now. You guys have understood. Y equal to sec x होगा, तो I hope y dash is going to be sec x tan x. This is for a very quick revision so that you guys can revise. Sec x is going to be sec x tan x. Next, y equal to cot x is there, then y dash or dy by dx is going to be minus cosec square x. Next, if I am having y equal to cosec x, then we'll be having y dash as minus cosec x cot x, right? These will be having to exponential taken care of, logarithmic we have taken care of, exponential we have actually not taken care of. Can you guys tell me this? If let's say we are having y equal to a to the power x, a to the power x. Can you guys try this? Prakal? नहीं logarithmic method क्यों लगाना है भाई?
So we can try it like y log of y equal to x into log of a, and like that we can solve.
Okay, don't you remember this result? ln y equal to x ln a, yes. But how we can do next? 1 by y dy by dx equals to x का is going to be 1, so ln a. So dy by dx is going to be y times ln a. Y is a to the power x ln a. Please remember this result directly. You will not be having the time or the leverage to solve this or prove this all the time. So please memorize this result. Memorize this result directly. Memorize this result directly. ठीक है, so this is what we'll be having. Trigonometry we have taken, logarithmic, exponential, ITF will take now. ITF will be taking y is sine inverse of x. This will be giving us y dash as 1 by root of 1 minus x square. Y equal to cos inverse of x if we'll be having. This will give us y dash as minus 1 by root of 1 minus x square. Next, if we'll be having y as tan inverse of x, then we'll be having y dash as 1 by 1 plus x square. If we have y as cot inverse of x, this will be giving us y dash as minus 1 by 1 plus x square. I'm writing very fast. I know. Firstly, so you have to recall all of these in your own head. And if let's say you are not able to recall it properly, then you have to just check what I'm writing on the screen and then move ahead with. Right. Next, y equal to, let's say, sec inverse x. Can anyone tell me sec inverse x? Can you guys tell me sec inverse x? So this will be giving us y dash as 1 by mod of x root of x square minus 1. And if you ask me cosec inverse x, so y equal to cosec inverse x, will be getting y dash as minus 1 by mod of x root of x square minus 1. These are some of the direct things we will be having. ठीक है? Next is going to be let's say differentiation of composite functions. Same thing we call as chain rule also. Composite functions. Same thing we call as chain rule also. So what exactly will be happening here? Let's say we have y equal to f of g of h of x, and we have to find the dy by dx. We have to find y dash. That is going to be, firstly you will differentiate the outer one. I hope you do understand this. F dash of g of h of x will differentiate the outer one, right? And then this is done, this bracket is done, right? We'll be differentiating the outer one. Then we'll be multiplying this by g dash of h of x, and then we'll be multiplying this by h dash of x. So yeah, I hope you understand this. Very quickly, just try this. Log of sine x square plus 1. Please try this very quickly. Log of sine x square plus 1. जल्दी differentiate this please. Y equal to log of sine of x square plus 1. This is what we'll be having. Very quick please. Getting answer from people. Yeah, almost same I think. So y dash is going to be log of something will give us 1 by that something. 1 by sine of x square plus 1. Now you will be differentiating this. Sine of something will give us cos of that same thing. And now you have to differentiate the x square plus 1 also, which is going to be 2x. So you will be having 2x cot of x square plus 1. So I hope you guys will be able to do this. Rohit, cos x square plus 1 by, yes, same thing you are saying, just cos of x square plus 1 by sine of x square plus 1 can be written as cot of x square plus 1. So I hope you will be able to do that also. Right. Next, chain rule and composite function I told you. Next is going to be implicit functions. I hope you do understand what are implicit functions. Implicit functions. So let's say we are having x square plus y square plus 2gx plus 2fy plus 2hxy plus c equal to 0, something like this. So what exactly we'll be doing is, we'll be differentiating both sides, with respect to x. So first we will be differentiating x square, which will be giving us 2x. Then we'll be differentiating y square, that will be giving us 2y. But we have to differentiate y also with respect to x. So we'll be having dy by dx plus 2gx में x का differentiation will be 1, we'll be having 2g plus 2fy में y का differentiation will be dy by dx. So 2f dy by dx plus this will be slightly tricky, guys. This will be slightly tricky. I am solving this. Differentiation of x will be 1, so just y. Differentiation of y will be dy by dx, so x dy by dx, and plus differentiation of constant is 0. So this is exactly how. Next what you will be doing is collect or combine coefficient of dy by dx. This is how you'll be doing. You'll be combining or collecting or taking common the coefficient of dy by dx, and this is exactly how we'll be finding dy by dx in these kind of cases. This is known as implicit functions. ठीक है. Exponential का I have given you hint. Logarithmic function I'll tell you. Logarithmic differentiation. You have to move little fast to cover those many topics. Logarithmic differentiation, so that will be used for the cases, let's say we have fx to the power of gx, a function raised to the power another function. So we'll be having log on both sides. We'll be having something like this. Just a second, ln of f of x to the power g of x. You know, ln has a property that the exponent will come to the front side. So we'll be having this as ln y equal to g of x ln f of x. Okay, something like this. And now definitely you can use u dot v rule. I hope you guys do understand that uv rule. Have we discussed those? Abhi discuss nahi kiya na? So we'll discuss those firstly. Okay, uv rule and all those things. So what exactly those rules say? Those rules say कि if let's say you are taking d by dx of or d by dx of f of x plus minus g of x, this is going to be f dash of x plus minus g dash of x. This was easy, Bilal. This was easy. Please look here, Sayed. But slightly tricky is the next ones, the product rule ones. So if let's say you have to find the differentiation of f of x into g of x, or we call this as u into v also. So remember this as u dash v plus uv dash. So this will be having f dash of x into g of x plus f of x into g dash of x. This is exactly what we'll be having in these cases, right? And third one, even slightly more tricky, d by dx of f of x by g of x. These kind of questions. So we'll be having g of x whole square, f dash of x, differentiation of first function. So yeah, I remember this as u by v, differentiation of u by v. So what exactly we'll be having? U dash v minus uv dash by v square. So denominator ka square, denominator whole square, differentiation of first into product of second minus first as it is, differentiation of second. This is quotient rule. This we call as quotient rule. The above one we call as product rule. So product rule and quotient rule are the most frequently used rules along with chain rule. So chain rule, product rule, quotient rule, these are most important, right? So this is done. Next is going to be, so these rules we studied, logarithmic we studied. Next is going to be parametric differentiation. Parametric differentiation. I hope you understand what is parametric differentiation. Parametric differentiation. So this is a kind of function, let's say, where x is given as a function of t, y is given as a function of t, and you are supposed to find out dy by dx. So what exactly you'll be finding? You'll be finding dy by dt, and then you'll be taking dx by dt, and you'll be taking the ratio of both of these. So dy by dt by dx by dt. This is exactly what will be giving you dy by dx. सही है? So this is also sorted, and the next one we will be having is ये हो गया higher order derivatives. Next one is higher order derivatives. Higher order derivatives. So let's say if we have to find out d2y by dx2, d2y by dx2. So I hope you understand this is d by dx of dy by dx. So you firstly find the first derivative, and then you find derivative of this also. This is how you'll be finding the second order. If you have to find the third order derivative, d3y by dx3, so you'll be differentiating whatever you have obtained in the above step with respect to x again. So this was majorly about the theory of differentiability or methods of differentiation. If you have any doubt in this chapter, please let me know. Definitely there will be some good questions that you might have solved and that are your doubts from this chapter. No?
No, sir.
यार क्वेश्चन तो अच्छे हैं इस चैप्टर के. Do we have some time? नहीं है तो very quickly we'll go through the theory of all of this, and then if we are left with some time, then we can do this. ठीक है, so this is done. Next we'll be moving on to applications of derivative. We have understood how to find the derivative. Now we'll be moving on to the applications of derivative. How exactly we can apply these derivatives in a real life. So definitely the syllabus part is firstly application of derivative chapter is for 4 marks. This chapter will be there for 4 marks, but yeah, one 3-mark question will be there, one MCQ question will be there. So there is going to be one question of 3 marks and one question which is MCQ. So this will be the format for this, right? This is what we'll be having here. So first thing that we need to study in this is rate of change. So very quickly we'll go through the theory, and then maybe we'll solve questions from one of the sample paper at least, and then try to understand what kind of questions are coming. ठीक है, rate of change. Rate of change is, let's say if there is a change in y, you can see from here, let's say this was the condition, this was x1, this was, let's say, x2. You can see there is a change in value of y also, like this. So change in y with respect to change in x, so you'll be calling that as delta y by delta x. Delta y by delta x, this will be y2 minus y1 by x2 minus x1. When this delta x is approaching to 0, when this delta x means we are bringing this very close, very close, then this delta x becomes dx. Delta x will be writing as dx and delta y will be writing as dy. So in this case, we'll be having limit of delta x approaching to 0, delta y by delta x, will be writing this as dy by dx, right? This will be instantaneous rate of change, instantaneous rate of change. And there are very good questions based on this topic. When the radius is increasing at a speed, like at a rate of 2 centimeter per second, what is the rate of change of area of the circle? Something like this. So those kind of questions are there. Instantaneous rate of change. These questions can be there, right? So you have to find out dy by dx at any given. Let's say you will be given x equal to any k, or if we were having whatever value we'll be having, we will be putting that value. So this is how we'll be finding a rate of change. Second is monotonicity. Monotonicity. Monotonicity basically deals with increasing or decreasing, increasing or decreasing. So you can have different kind of graph of a function. You might be having a graph where the values of x are increasing. So you can take this example. You can take this example. If you go from x1 to x2, you can see here if x1 is increasing, this will mean, or x is increasing. I'll not say x1. I'll just simply say if x is increasing, this will mean the value of y also increases. This was the initial value and this is the new value of y. Similarly, when we talk about the decreasing function, you can see something like this. So let's say this was the value x1 we are having and this is the value x2 we are having. So this was the value y1 and this is the value y2. You can see there is an increase in the value of x. So here there is an increase in the value of x, but the value of y is decreasing. Guys, what's the point if you're not interested? There is no point, man. Come on. So, so what exactly we'll be doing here? We'll be drawing a tangent at any point in this case. You can see the theta is acute. In this case, you can see the theta is acute. So tan theta is going to be positive. If tan theta is positive, means we'll say slope is positive, or we can say dy by dx is positive. In this case, if I draw tangent at any point, if you want, if I'm drawing tangent there, you can see the angle theta is obtuse. Theta is obtuse. If theta is obtuse, then tan theta after school to college, only sine and cosec positive, so tan is negative. Tan theta will be negative. That means slope is negative. That means dy by dx is negative. dy by dx is negative, we mean dy by dx is less than 0, and if dy by dx is positive, we'll say dy by dx is greater than 0. So these are the conditions for increasing and decreasing. In fact, this is a condition for strictly increasing. Strictly increasing. And this is the condition. Guys, इसमें definitely you guys can be tricked. I'm telling you. Inequality में interval change कर देगा. They might mention increasing, they might mention strictly increasing, they might mention decreasing, they might mention strictly decreasing. Please pay attention. ये 1 mark खा सकता है आपका. This is highly important. You guys should not be making an error here. So this is the case for strictly decreasing. Strictly decreasing. But if the question says f of x is just increasing, not strictly increasing or anything, this will mean that f dash of x is greater than or equal to 0. F dash of x is greater than or equal to 0. Doesn't have to be strictly greater than 0. Similarly, if someone says f of x is decreasing, if f is a decreasing function, this will tell that f dash of x is less than equal to 0. F dash of x is less than equal to 0. So please ensure this you are not making an error. Strictly increasing means greater than 0. Increasing means greater than equal to 0. Okay? This is done now. This was the part of monotonicity, and last part of this chapter, which is maxima and minima. Maxima and minima is what we'll be having here, right? Maxima and minima. So I hope you do understand there when we say that we are getting a maxima. Let's say if I ask you this, ये yes or no question है, ठीक है? X equal to 0. This is the graph of y equal to mod of x. Can I say x equal to 0 is a point of minima? Can I say x equal to 0 is a point of minima? Yes. Sayyid Bilal is saying, sir, I will be rejoining soon as I have something to do. What do I mean, man? I don't understand this. Say that I don't understand, man. Can you unmute yourself?
No, I just meant I'll be leaving right now. I'll be rejoining in a while. I have something to do right now. So I'm just taking excuse.
Okay. Cool. So yeah, this is a point of minima. Minima means value is lower or lesser than immediate neighborhood. Immediate neighborhood. Matlab, if you check for the left side or you check for the right side, if the value is the lower value, you're getting a lower value, lesser value, that is when you will be saying this is a point of minima. And when I say maxima, this is the definition of maxima will be having, that value will be more. Value is more than immediate neighborhood. Immediate neighborhood. Right? This is exactly what we'll be having in this case. Value is more than immediate neighborhood. So now there is going to be first derivative test. First derivative test. So what exactly we'll be doing is, if let's say a function will be given to us, I'll show you this and I'll show you another example also, something like this. So let's say this is y equal to f of x ka graph and this is y equal to g of x ka graph. These two graphs are given. You can see here in this part, f dash x is greater than 0. At this part, f dash x is less than 0. So you can see this. Let's say this is x equal to a and let's say this is x equal to b. So for case 1, what exactly will be having? What exactly will be having? F dash x is greater than 0 for x less than a and f dash x is less than 0 for x greater than a, and most important, f dash of x should be 0 at x equal to a. Most important, most important part. Then we'll be saying, then this will be saying x equal to a is a point of local maxima. So yes, if your values were increasing, and the rate of change became 0 and then started decreasing. So increasing and decreasing, definitely you understand it's a maxima. And if I show you for the second case, for case 2, you're having f dash x is less than 0 for x less than a and f dash x is greater than 0 for x greater than a. So it was decreasing, then it started increasing again. In that case, we'll be having the minima as long as f dash x is 0. F dash x is 0. F dash x is 0 at x equal to a. This will, in this case, will be saying x equal to b is, acha, f nahi tha, g tha. Sorry, we were having a different function this time. We were having g here. We were having g dash of x, g dash of x, and g dash of x in all the cases. So this will be saying is a point of local minima. The values were decreasing, and then started increasing after a point. In that case, we'll be getting a local minima. Right? Do you guys know about absolute minima and absolute maxima? Absolute minima. This will be saying the point where function attains the minimum value in an interval. What do I mean by this? Let's say I was having a graph of this type, something like this. Yes, so definitely you can see this is the minimum value. This is the minimum value. So this is going to be your absolute minima. Absolute minima. This is going to be your local minima. This is going to be your local minima. And similarly, this point is going to be your local maxima. Local maxima. And this point you'll be having as absolute, or sometimes we call this as global also. This will be global maxima, you can call it, or absolute maxima, you can call it. Right? This was your first derivative test. We have second derivative test also. सेकंड डेरिवेटिव टेस्ट, एक सेकंड देना मेरे को, second derivative test. So what do we say by this? Let's say if f dash x is 0 at x equal to a, f dash of x is 0 at x equal to a, and if we have f double dash of x is greater than 0, then we'll be getting, what do we get? What do we get in this case? Maximum or minima? हाँ भाई,
Minima.
we'll be getting a minima in
Minima.
this case. Yes. And if we have f double dash of x as less than 0, what do we get in this case?
Maximum.
Maximum. Right? So I hope things are sorted till here. So we have covered the theory of both the chapters. Now I am ready to take your questions. If you have any doubts, you can ask me from any either of these chapters. If you have any doubt, you please let me know. I'll solve that question for you guys. Yeah, no question. So then what we can do is we can do previous year question, board PYQs. Have you done 23 questions? हाँ भाई, 23. Chalo, if you have not done this, then we'll try to find these questions on these chapters. This, if differentiation of f of x is log x, अच्छा ये तो इंटीग्रेशन का आ जाएगा ना, तो लेट्स नॉट गेट इनटू दिस. ऑर्डर डिग्री ये भी अलग है. Then ijk direction cosine, this continuous function. Can you guys tell me the answer to 13th question quickly? The value of k for which this function is a continuous function. Can you guys tell me the value answer to this question quickly? Guys, can you tell me the value of k?
So just a second.
11 by 4.
11 by 4.
Wait,
If we
so
put in the
one.
RHL, you'll be having 3 to the 6 plus 5, 11. And if you put in the left hand side, it will be 4k. So what exactly you'll be having in this case? You'll be having this as 11 and you'll be having this as 4k. For this function to be continuous, 11 has to be equal to 4k. This gives us the value of k as 11 by 4. Okay? This is sorted. Can you guys look at this question 16th? Strictly decreasing function. Can you guys tell me this? Strictly decreasing function. Strictly decreasing function. I hope you do understand. For strictly decreasing function, we'll be having f dash of x as less than 0. Please solve this quickly and let me know the answer. आ रहा है भाई आंसर? क्या हो गया? A into x minus cos x. So this is going to be f dash x is going to be equal to A as it is 1 minus minus plus sine of x. This value is strictly decreasing, matlab less than 0. So we'll be having 1 plus sine of x less than 0 and we'll be having sine of x less than minus 1. Sine of x less than minus 1. What are we going to have here? बोलो भाई बोलो. a into 1 minus minus plus sin x is less than 0. A, we can divide both sides by a. We can subtract 1 from both sides. Sin x is going to be less than minus 1. So definitely we don't want sin of x as 1. We don't want sin of x as 1. And where do we get the value of sin x as 1? बोलो भाई. इसमें a into 1 minus minus plus sin x less than 0 divided by a done 1 plus sin x this sin x less than minus 1 sin x not equal to 1 मतलब x not equal to pi by 2 और x not equal to 4n plus 1 pi by 2. इसमें ऑप्शंस तो वैसे नहीं दिए यार इसने. प्रगल्भ सोल्व कर रहा है क्या क्वेश्चन?
हाँ सर, ट्राई तो कर रहा हूँ.
लेकिन आंसर तो यही आना चाहिए ना, x not equal to pi by 2.
सर you have to
लाइक
find a, like not x.
अच्छा, ठीक है, ठीक है. तो when will this quantity be less than minus 1? ठीक कह रहा है, मैं उस पर दिमाग लगाने लगा था. x तो दिख रहा, हमें देखना है a. What should be a? अब बताओ.
Sir, but like a can be any number, right? Any positive number.
No, if we take a as 0, let's say if we take the first quantity a as 0, then this will become 0. But 0 into something will be 0. 0 will not be less than 0. तो पहला तो ये तो कैंसिल ही हो गया, राइट. wherever we have 0, that option will be cancelled for sure. अब ये देख लो, पॉजिटिव वैल्यूज चाहिए कि नेगेटिव वैल्यूज चाहिए. समझ रहे हो मैं क्या कह रहा हूं? ए तो ले लिया. इफ वी टेकन 0 ना, डेफिनेटली दैट विल नॉट बी आंसर बिकॉज 0 into समथिंग विल बी 0. 0 कैन नॉट बी द आंसर. नाउ वी नो दैट. अच्छा, इसमें तो हमें जरूरत ही नहीं पड़ेगी. विल नॉट हैव टू सॉल्व एनी ऑफ दिस. जस्ट वी कैन प्रिडिक्ट फ्रॉम हियर ओनली. So we are having f dash of x as a times 1 plus sin x. This quantity, because this quantity will always be positive. This quantity will always be positive. बताओ कोई डाउट इस बात में? Because sin x can be at the max minus 1. So this quantity will always be greater than equal to 0. Greater than equal to 0 होगा. Yes or no? अरे
Yes.
बोलो भाई. So this will have to be a negative quantity to make the whole product negative. So a has to be negative. A has to be negative मतलब minus infinity to 0. C will be your answer. सही है, ठीक सा दिमाग लगवाया क्वेश्चन ने. डिसेंट क्वेश्चन. आई वाज फोकसिंग ऑन एक्स बट वी हैड टू फोकस ऑन ए, राइट. और देख लेते हैं कुछ ऐसा मिलता है तो. फंक्शन इज गिवन सेट वेक्टर. हाँ, ये वाले क्वेश्चन देख लो भाई. ये डिफरेंशिएशन के क्वेश्चन है. ट्राई करो ये क्वेश्चन. हाँ भाई. तो विल फाइंड. देखो इसमें कुछ नहीं करना. विल बी फाइंडिंग dy by dx एंड विल बी टेकिंग स्क्वायर ऑफ इट एंड देन विल बी मल्टीप्लाइंग. लेफ्ट हैंड साइड को व्हेन विल बी सिंप्लीफाइंग डेफिनेटली विल बी गेटिंग एज राइट हैंड साइड फॉर श्योर. ठीक है, ट्राई कर लेना. आई एम सजेस्टिंग कि 25th कर लो अगर तुम्हें करना है. 25th इज comparatively logical question. 24th is more of labor work. 25th is more logical. ये कर लो भाई. And I don't think you guys are solving much questions if you're not asking doubts. रोहित का लास्ट आंसर was correct. रोहित, yes. Please tell me this also. अच्छा, ये तो शो करना है ना, स्ट्रिक्टली डिक्रीजिंग. एफ डैश कर देंगे इसमें भी. शो करने वाले में क्या करें? शो करने वाले में विल नॉट हैव टू यूज मच. ये तो वैल्यू निकालनी होती. Mm. Last now. ये एक लास्ट क्वेश्चन कर लो यार. दिस इज अ क्वेश्चन which is based on this topic. You do this question and we'll be done for the day. Just this one last question and then we'll be done for the day. अच्छा, ये वाला भी, नेक्स्ट वाला भी बढ़िया है. F double dash at, ये इजी है. नेक्स्ट पार्ट इज इजी. दिस इज स्लाइटली ट्रिकी, तो ये कर लो, देन विल बी डन फॉर द डे. लेट मी इसको, आई टेक दिस टू द नेक्स्ट स्क्रीन. Do it quickly and then we'll be done for the day. And I'm coming back in a minute from washroom. जल्दी. हाँ भाई, हो रहा है. चलो, लेट्स लुक एट दिस क्वेश्चन. कोई आंसर आया क्या? डन सर. अच्छा नहीं, यस सर. प्रगल्भ इज रीडिंग द आंसर. प्रगल्भ बताओ भाई जल्दी से. अ टैप इज कनेक्टेड टू सच अ टैंक हुज कॉनिकल पार्ट इज फुल ऑफ वाटर. ठीक है, कोई टैंक है विच इज इन द शेप ऑफ अ कॉन. ठीक है, या कॉन के ऊपर और भी कुछ है?
No, sir, only the
कॉनिकल पार्ट. हाँ, वाटर इज ड्रिपिंग आउट फ्रॉम अ टैप एट द बॉटम at the uniform rate of 2 centimeter cube per second. ओके, इसको थोड़ा सा बनाने में दिक्कत आएगी. Something like this. So this is going, the water is dripping from here. Let's say यहाँ से water जा रहा है at the rate of 2 centimeter cube per second. Yes. And the semi-vertical angle of the conical flask is 45 degrees. I hope you understand the semi-vertical angle also.
So the radius and height are equal.
Yes. So whatever is the radius, same is going to be the height also. So radius equal to height. Very good observation, Prakal. And what else is there? What tap is connected this, whose conical part is full of water, what is dripping at this, and uniform rate of this, semi-circular angle is this. Find the volume of water in the tank in term of its radius r. तो volume of water कितना हो जाएगा? 1 by 3 pi r square h, and h is also equal to r, तो 1 by 3 pi r cube. यही आया क्या? ठीक है.
Yes,
Find the
sir.
rate of change of radius at an instant. नहीं, radius नहीं आना चाहिए यार.
Sir, rate of change of radius is possible.
कैसे बताओ?
Sir, we are given dv by dt, so that is the dv by dt is dv by dr into dr by dt. So you
dv by
can find
dt,
dr by dt from there.
dv by dr into dr by dt.
Yes,
Yes.
sir.
And what's the value of dv by dt you're taking?
dv by dt I'm getting as 2. It's given in the
2.
question.
Okay. And dv by dr we can find out, yes, this is 3 will be cancelled. So 3 by 3 into pi r square into dr by dt. So you are given the value of r. So this will give us dr by dt as 3 by pi r square. So that will be 3 by pi into r कितना था? R is 2 root 2. 2 root 2 है ना? हाँ. 2 root 2 का
Sir, it will
square.
be 2 divided by the value.
Why?
The dv by dt is 2.
dv by dt is 2. So we'll be having this dr by dt as 2 will be there in the numerator, right?
And yes, sir, 3 won't be there in the numerator.
3 won't be there, 2 will be there. That's a typo. Yes, that I understand. So we'll be having this as 2 divided by pi into 2 root 2 square. So this will be 2 by 8 into pi. So 1 by 4 pi. सही है क्या?
Yes, sir.
1 by 4 pi centimeter per second. Next will be find the rate at which the wet surface area of the conical flask is decreasing. Wet surface area is decreasing. Yes. How do we find that, Pragal? Surface area. What is
Sir,
the
the
surface
wet
area of
surface area is pi into r into root 2r. So root
नहीं,
2 pi
एक
r
मिनट
square.
एक मिनट एक मिनट. What's the formula for surface area? What's the formula for this?
Pi r l. L. Pi r l.
Pi r l. And what's the value of L?
Root 2 into r.
Root of r square plus r square. तो r root 2 आ रहा होगा मेरे हिसाब से तो.
Yes, sir, root 2r.
हाँ, root 2 r root 2 r. Yes. Then so this is pi r l.
So
फिर
pi
what can we
into
do from
root
here?
2 into r square is the wet surface area.
Wet surface area. We'll call this as, let's say, S. We'll be finding this with respect of r or t.
Sir, t. Because we
Because
have
it's
been given dr by dt.
dr by dt. We are not given, but we have found it. या दे रखा है उसमें.
Sir, we just found it that 1 by
We
4.
have found it, but it's not given to us. But we have found it. So ds by dt is going to be pi r into r root 2. So pi root 2 is there, r square is there, r square. So r square का differentiation of this with respect to t we are calculating. R into r will be r square. So we'll be having 2r dr by dt. So pi into root 2 into 2 into r into dr by dt is 1 by 4 pi. So this will be cancelling this as 2 and pi will be getting cancelled. Or r की value I think is given to you. है ना? 2 root
2
2.
root 2.
So we'll be having this as root 2 into r, which is 2 root 2 by 2 to root 2 cancel. That will be 2, right?
Yes, sir.
2 centimeter square per second. Find the rate of change of height h at an instant when slant height is 4 centimeter. Plant height is given to us as 4 centimeter. इसमें क्या करेंगे? Rate of change of height. तो we want dh by dt. बताओ.
Sir, dh by dt can also be written as dr by dt because again it is like same as
Same.
radius.
बिल्कुल, because the angle is 45
And
degrees. So angle is 45. So radius and height are same. So what should be the answer in this case?
And slant height is again root 2 pi r square. So we can differentiate with radius over there.
We can differentiate with this, right? So dh by dt we need, which is going to be dr by dt. L we have found above step, na? L was r root 2. L is r root 2. What do we need in this case? Or are you writing this as L as h root 2? ऐसा लिख रहा है क्या?
So it would be same only because r and h is equal.
हाँ, R and H are equal, so better we take because they're given rate of change of slant height. Now this time dl by dt equal to root 2 as it is. This is what we'll be getting in this case.
Sir, how?
यही आएगा या हाँ और into dh by dt भी आएगा. What do you say?
Yes, sir. Yes, sir.
Into dh by dt will also be there, and that is also going to be same as dr by dt. And what was that value? Dr by dt value was 1 by 4 pi. So this is something we'll be having root 2 by 4 pi centimeter per second.
Sir,
सही है
but
क्या?
dr by dt is only when r is root 2, that value.
Hmm?
Sir, dr by dt value is like only 2 is 1 by 4 pi only when r is 2 root 2.
Okay. So what do we have here? Then what should we be having in this case? If let's say you are saying when the slant height is changing at the rate of 4, so dl by dt we are given in this case. So dh by dt will be finding here, na?
Yes, sir, 4 by root 2.
We will not be putting this value. We'll be putting the value in case of dl by dt, which is given to us as 4 equal to root 2 into dh by dt. And this gives us dh by dt as 4 by root 2, which is 2 root 2. 2 root 2 centimeter per second. सही है? Same
Yes,
आया
sir.
ना? I think the answer is same, I hope. हाँ, 2 root 2 दे रखा था ना उसमें, 2 root 2 आया है. ठीक है, तो these are the kind of questions you'll be having from these chapters. Differentiation के questions you guys can practice, right? So please practice PYQs and you'll get to solve good questions from there. Okay. All right,
Yes.
guys, we are already 10-15 minutes past the time. So enjoy. Have a good night. I'll see you again later. Bye.
Thank you, sir. Bye, sir.
Thank you, sir.
Bye. Bye.